Welcome back to GPU Talk. In this video, I'm going to be showing you how to install NVIDIA's Virtual GPU software. We'll be covering all the steps needed to get a virtual desktop up and running with a virtual GPU. The way Virtual GPU works, there are a number of components. There's the hypervisor itself. At the moment, NVIDIA supports vSphere, Citrix, KVM and Nutanix with Virtual GPU. In this video, we're going to be covering the installation process for vSphere and Citrix Hypervisor. On top of the hypervisor, there is the GPU manager from NVIDIA. This package is unique to your hypervisor and allows you to split up the GPU between multiple VMs so that these VMs can get a time slice of the GPU's resources. There is a GPU license server. We covered that in another video available on this same channel. And finally, there are the NVIDIA GPU drivers that we install inside the virtual machines themselves. All of the GPU virtualization underneath this is transparent to our applications and operating systems, which use the GPU as if they have direct access to a local device. So the first thing you'll need to do is download the server and virtual machine software from NVIDIA's licensing portal. If you bought a license or have started an evaluation, you'll have the details you need to log in here. This is the same place you go to manage your vGPU licenses, except this time we're going to choose the Software Downloads tab, and by running through the filters, you'll be able to land on the correct packages for your hypervisor. As we're going to be installing onto XenServer 7.1, we can download the latest version available for that hypervisor, which is 10.1. As I'm also going to be showing you vSphere, let's also download the ESX 6.7 bundle too. Once you've unzipped the packages, you'll see that we have Windows and Linux VM drivers and our GPU manager packages. Now we need to use something like WinSCP to copy those files down to our hypervisors. Once that's done, let's start with XenServer. Let's use the lspci command to see if the GPU is being seen by XenServer. You can run this on VMware too, by the way. And also, let's just verify our GPU manager package is there. Okay, so all we need to do now is use the RPM installer to install the GPU manager. And when it's complete, let's reboot and verify the install went correctly. So after a reboot, we can see that the NVIDIA SMI command returns back some information about the GPU. Everything is looking good in this case. We can also use a couple of other commands to see if the GPU manager is loaded. In both cases, the commands here are returning what we'd expect. If you look in XenCenter, you'll see that the GPU is available and you can configure the placement policies and whether we're setting this up for virtual GPU or GPU pass-through. GPU pass-through is another method of consuming a GPU where you pass the whole GPU through to just a single VM. So now let's install the GPU manager software onto our VMware server. First, put the server into maintenance mode and access the console via something like PuTTY. So after a quick check to see we have access to the downloaded software, let's use the ESX CLI command to install the GPU manager VIB. Make sure you include the full path to the VIB file here. If you don't do that, it won't install correctly. So after a reboot, let's once again use a few commands to verify the installation. All this is looking normal, and if you use NVIDIA SMI, you'll notice that we can see all three GPUs that we have installed in our server. Bear in mind that in this case, this is a test server and a combination of different GPUs in the same server isn't supported in a production environment. Before we go to the next step, there are just a few things that we need to configure in vCenter. First, we need to go to the graphics section of our host and make sure that our graphics are set to Shared Direct. Shared is the default, so make sure you've selected Share Direct and reboot the server before continuing. You can also see the GPUs and any VMs that you've got running on them from this same place. Also, bear in mind that if you're going to be live migrating vGPU enabled desktops between nodes, you're going to need to enable Hot Migrate in the Advanced vCenter settings screen. One thing you've probably noticed by now is that we're using vCenter for all of our management operations. Bear in mind that in order to use vGPU with VMware, you need to have the Enterprise Plus edition of VMware or above. So now, before we start allocating GPUs to virtual machines, let's just build a standard Windows desktop or server VM. After the installation is complete, we're going to install the appropriate hypervisor tools. I'd also recommend enabling remote access to your VM at this point. In the case of VMware and most other hypervisors, you're going to end up with a black screen on the virtual machine console after you plug in the GPU, so you'll need an alternative way to gain access to your VM afterwards for further configuration. The next thing I'd recommend is to run Windows Update before installing a virtual GPU. If you run Windows Update in between plugging the virtual GPU in and installing the vGPU drivers, Windows Update will see a GPU without a driver and will install the DCH driver automatically. This is fine if you're on a physical workstation with a GPU, but the DCH driver is not compatible with vGPU. So, the way we allocate portions of the GPU to each VM is using GPU profiles. Each VM gets a time slice of all of the cores of the GPU, but each VM also gets its own dedicated frame buffer for its own usage. For example, the profile we're about to plug in looks like this. T4 is the name of the GPU. 1 is the amount of frame buffer in gigabytes we're allocating to our VM. And B is the type of GPU license, which dictates the functionality you're going to get. A profiles are for server-hosted desktops running on Windows Terminal services. B profiles are business or office worker profiles. Virtual compute server profiles for deep learning and HPC workloads are C profiles, and Q are Quadro VDWS licenses for graphics professionals. If you want to know more about profiles, check out my introduction to vGPU video or look at the documentation. So let's allocate a GPU profile to our VMware VM. Let's use our example profile T41B. This is a good profile to start with for a low-end Windows 10 desktop for an office worker running something like Microsoft Office and maybe some basic video-based applications. We're also going to make sure we reserve all the VM's memory, which is a requirement for shared PCI devices and stops memory from being overcommitted by the hypervisor. So let's take a look at XenServer. You'll see here that we don't have access to our vGPU profiles yet. This is because inadvertently I let the XenServer entitlement I got with my Xen desktop implementation expire. This is a great reminder that in order to use vGPU with XenServer, you'll need to have the pay for version, the same as you need the Enterprise Plus version for VMware. Now that I've renewed my license, you'll see that I have access to my virtual GPU profiles. So let's go with a P4 2Q profile. A 2Q profile is a good starter profile for a low-end graphical professional running something like AutoCAD or Revit. So we've now installed our GPU manager on the hypervisor, created a base image and allocated a virtual GPU to it. So let's move on to the next step, which is installing the NVIDIA GPU drivers into our guest VM. This next part is the same for both XenServer and VMware. So after booting our VM, let's just connect via RDP and copy the NVIDIA device drivers to our image. Remember, this is from the driver package that we downloaded from our license portal earlier. Also notice that at this point Windows doesn't know anything about the GPU and has loaded a generic device driver. Now we just need to run the installer, select all of the defaults, which will give us everything we need, and reboot our VM. So now there's one final task that we need to do. We have to tell the driver where the NVIDIA license server is so that we can get full performance out of our virtual machine. You'll now notice that the OS recognises the GPU profile. We'll just open up the log file location here so that we can check that the license gets allocated correctly. Now right click the desktop and open the NVIDIA control panel. In here under License Manager you'll need to enter an IP address and port number which you'll know from your license server installation. Port 7070 being the default port that we use. If we look in the log file now, you'll see that a license was successfully checked out based on the vGPU profile that we gave to the VM. And if we look in the control panel again, you'll see that we have the correct license. Licenses are allocated to VMs on boot rather than when the user logs in. So make sure you have enough licenses for each booted VM that has a vGPU profile allocated. Let's just have a quick look in Task Manager to make sure the GPU is performing as we'd expect, and maybe run a video or even a WebGL application to see if we have some activity on the GPU. We're now at the point where we can install the remoting agents for our chosen VDI product. I'd recommend you leave this step until last to make sure the agents get configured for virtual GPU correctly. Okay, so now we're up and running with our vGPU enabled virtual desktop. One thing to point out is that if you're going to be using any provisioning technologies to clone this base image you're building, I'd advise that you follow a few additional steps to anonymize the image before use. These are covered in my YouTube video on 15 tips for GPU success. I hope you've enjoyed this video. If you want further help with sizing and testing virtual GPU, please check out the other content on my channel. Thank you.